Hi everyone, we're going to do information about y equals the parent function log of x. This is the common log, and basically it means that the base is 10. When they don't give you the base, it means it's base 10. And before we can graph this, we need to know the table of values for y equals 10 to the x. And since they're inverses of each other, what we're going to do is switch the x and the y, and so we're going to graph it like this. Like that, okay? So let's go ahead and graph it. And so 1 goes to 0. Then we're all the way down here. And then we've got 10 goes to, let's see, let's go back. So 10 goes to 1. So we go all the way down to 10. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically right around here. So there's your log function. All right. Now, the information is what's the domain and range. So in this case, since we're graphing the log, the domain is x is greater than 0. Because remember, we're switching the x and the y's, whereas your y is all real numbers for the range. Okay. There is a 0 here. The 0 is at 1, 0. Where is y positive? Y is positive. So y is positive where x is in between. We're looking at the x. So x is in between 1 and infinity. All right. Y is negative. So that means in quadrant 4 between 1. So we'll start at 0 to 1. All right. So basically from here to here is where your y is negative. And when you talk about the interval, you're talking about the x values. And it can never, okay? So now we got to discuss the end behavior. The end behavior, you're looking at these arrows here. So I want to know when y is approaching infinity. So as this gets bigger and bigger, which doesn't look like it is, but it will. So as y approaches infinity, that means x is approaching infinity. Okay? As y is approaching negative infinity, which is down in here, okay, x actually is going to the left here. All right, so it's actually going to 0. It's getting closer and closer to 0. All right, but it's going negative, but it's still positive. All right, the function is 1-to-1. There's no symmetry because it's not symmetric to the origin nor the y-intercept. The inverse function of this is just y equals 10 to the x. So if I graph y equals 10 to the x, that would be here, way up here, and way down here. So this would be y equals 10 to the x. You're just switching the x and the y's, and we already did that table. Here's your original. It just tapers off here. So it reflects over the y equals x here. All right? So this is our original function, and this is your inverse function that they want. You just switch the x and the y's. All right, and then to do the transformations, we want y equals log of x minus h plus k. So let me graph the original. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. down here. So there's the original. And let's go ahead and shift this to the left this time. So to the left would be log of x minus, let's shift it over by 2, negative 2. Right, so which is really y equals log of x plus 2. That means it's to the left. So I'm just going to take these points and go to the left by 2. And this goes by 2. And this goes by 2. All right. If you notice that before we had a vertical asymptote at x equals 0, now we have a vertical asymptote at x equals negative 2. So when I graph this, it's going to be like this. Okay, so basically something like that. All right, now the thing that changed here was the domain, because we're doing a horizontal shift. Remember, the domain of the purple graph, the original, was x has to be greater than 0. Now for the new domain, it's going to be x is greater than negative 2, because we shifted this to the left. All right, now for the horizontal, or the vertical shift, let's just do log of x. Let's shift up by 3. So I'm going to take my original and go up by 3. So 1, 2, 3. Here we're going to go 1, 2, 3. And this is just going to 1, 2, 3. So basically it's just that. I just shifted the whole thing up by 3. In this case, the domain stayed the same. All right? The domain for this is x is greater than 0. Because we did a vertical shift, we didn't change the x values. Okay, that's all of the common log. The next one we're going to do is the natural log, which actually is the inverse of y equals e to the x. Thank you and have a nice day. Bye-bye.